Hey everyone, welcome back to the channel. Today's video we're going to be making some billet hub adapters for a hub dyno. If you don't know what that is, I'll drop a picture in here real quick to give you an idea. You can use on front wheel drive, rear wheel drive, and all it is we're unbolting the front or rear tires and we're installing hub adapters to where the tire and rim would go, and then we're connecting the hub adapter to the hub dyno. Typically we have two brands that we deal with are either going to be a Dyno or a mainline dyno, both the same. This one particular is going on a Dyno dyno. So over here in the lathe, and this piece started out as a 10-inch round billet, okay, 4 1/4 inches long. You can hear the mill going off in the background. Now the mill is roughing down a more of a square piece that we purchased. Easier to get that than a 10-inch round cut in this thickness. Two things with that square piece is it is a little too tall. It's about 5 inches tall. We need to mill it down, which it's doing now, mill it down to 4 1/4 inches tall. And then what we're going to do is rough in a radius on that piece pretty far down to be able to chuck it off into the lathe. Now I have my crummy jaws in here. I wound up welding some steel pieces to it, made it the easiest way to do it, and I brought in my boring bar and gave them a radius so that it's even in the lathe jaw. We chucked up this piece here, and the ID bore is done, and not as perfect as I'd like it to be, because just trying to deal with a tool that is, I kind of have a mix between small, not too small, but small enough, like a 3/4 inch boring bar, to a 2-inch boring bar. So just attempted it with that. Worked out okay. Not totally satisfied with it, but for what we're doing here, it's going to be just fine. It's still within tolerance. Overall, this piece is about almost 10 inches, about 9.9 inches in the OD. We have a 1/2 inch thick flange here, and eventually the final OD here is about, I believe it's about 8 inches, give or take. The bore on the inside goes down 3.5 inches. And then from in there, right now there's nothing done. We're actually doing this in two processes. This will go back to the mill, get centered up in the lathe, indicated in, and we'll be drilling or milling the holes and putting chamfers in it for an acorn nut to hold it to the vehicle, to the axle. This is about as far as we're going to go with machining this on these current lathe jaw configuration. Once we get the other one up to the same level as this, we're going to put the good jaws in. We'll flip this over, put it in here, and then finish facing off to get it all done on the lathe for both parts. Then they're going to go back in the mill, and they're going to get some machine work done. Now we're going to have, I believe, 6 holes here on this flange that are critical to the Dyno pattern, so that this will bolt right up to the hub dyno. Alright, so I'll bring the camera in real quick and we'll see what's going on here, and we'll take a peek over on that machine there. See, I believe that's almost just about done. We might be able to catch it as it's finishing. I'll bring the camera in here, we'll take a look at the work we got. And then awesome, that's done, so we'll get to go see what that looks like. Like I said, I went up taking some pieces of steel onto my crappy jaws. That worked out pretty well. And we're going to leave that until we have to do the second one. Like I said, I had a little bit of chatter on the inside here on that radius. There's a large radius in here. This has to get a maximum of a 2.81 bore here for the largest 4-bolt pattern of hub bores, the hub diameter. Alright, we got a chamfer here. We're going to clean this up a little bit too before I finish taking this out. So this was pretty much done with my 3/4 inch boring bar there, and I also used my 1-inch index drill, which I'll show you that real quick and explain how I do that. Here's my index drill. I've had this for quite some time. What I wind up doing is I'll have both inserts in it. Now we're missing the center insert here. I'll have both inserts in it and drill the bore all the way through 1 inch. With a little bit of tweaking with the program, we can then remove that, okay, and then we can start to bore utilizing just the perimeter insert. Sorry. So it's really neat. I only go so far with it just to get enough clearance. I could probably go all the way, but just enough to open that up, that 1 inch, so the 3/4 could bore in there. I actually went about 2 inches with this tool, boring it out, drilling it, and then boring it out. So that was really useful using one of this. This is a 1 inch by 5D. All right, let's go back over to the lathe. So we drill that out, and now we kind of have a pilot hole, and then we start to go off with boring. I went from 2 inches with the 1 inch indexable drill, and then remaining with that. For this here, I just went up using I think my typical #1 tool. I forgot what that one is. I think it's a WNMG. Alright, so we just kind of faced it back, but then I used my Whittier paring tool here, okay? A little beat up like they all are, I guess, maybe. But what's nice about this is you can side load it and side cut with it. So I wound up just kind of coming down here, finishing off this surface, okay? And then roughing this down a little bit here, a little bit better. It did a finish pass, I didn't catch that, not a big deal. But I didn't allow it to do a finish pass here. So all it did was just kind of come in and start chopping away at this material so we don't have too much here. Just wanted to make it a little bit easier. It's pretty quick running this program here. Alright, so that's that. Again, we're going to be putting the other jaws in, flipping it over, grabbing it from the inside here, indicating it in, doing the bore, and finishing off the face of it. Alright, let's go over to the mill and we'll check that out. Alright, so I went ahead and just kind of blew it off, but you can see this was 5.2 inches tall. We brought it down to about 4.25. We still have room to go, so doesn't really matter if that's exact. But that used there is the Mari tool 4-flute. It's a great chip breaker. Pretty good cutter for just roughing down real fast. I run that at 10,000 RPM and about 160 inches a minute just to kind of whip through this. This was a 40 thou step over, full axial 40 thou radial, just to kind of rip that off, and that worked out pretty well. What I'm going to be doing to finish, to actually put a be careful, it's very expensive. To start, I want to go down pretty far. I think I'm going to go down about 3 inches. Okay, I'm going to use a full flute of that, and we're going to walk around and just do a radius. The majority of it's going to be taking away the corners here because we're 10 inches, so we're very close to our 9.925 diameter, which we're not going to hit right off the bat. We're going to let the lathe do that. But here we're going to utilize this tool here. This is a 1 inch core 5, Kennametal core 5. I think it's a fantastic tool, chip breaker. They're not cheap. So what we're doing is we're going to run this. I believe this is like, I only run this about 3,500 RPM, I think, because the surface foot is pretty good. And it's moving pretty fast. I actually have to slow it down. This is only a 20 horsepower machine. And it winds up tripping the breaker if I let it rip too hard. So what I'm going to be doing is just kind of coming down, just taking away most of the corners here. I'm going to break it up into 4 pieces and run a pocketing, or an adaptive, excuse me. I'll run an adaptive with this and just kind of chip away at it and get the corners out of the way, and then do a final kind of cleanup bore to make it smooth outside bore, circular, and then leaving a little bit on there. We don't really have to because I could do whatever I feel like doing, but I'm going to be doing it at pretty close to that because one side or the other, if this is the lathe side, the chuck side, excuse me, then most of that's going to be gone away. So we can still run it down comfortably so it's circular enough. All right. All right, so we're done with the lathe. We're back over here on the mill. These came out great. The one we had a chatter problem, I guess, with feeding. I did resolve that to clean that one up, and then we perfected it on here, so they really came out pretty nice for what their intended uses for. Now over on the mill, what we're going to be doing is we're going to be boring the holes. I believe there's 6 holes here. This is the pattern for the Dynocom dyno, the hub dyno itself. The bolt is to the hub dyno. And then on the inside, we're going to be doing 3 different patterns of lug patterns. This is for 4 lug patterns. So we have 4x100, 4x108, and 4x4.5. So what we're going to do is we're going to be boring those holes, and then as well as doing the chamfers for the acorn nuts to kind of help center this onto the hub of the vehicle. If you don't know, so this side, this would be your brake rotor side here. It's going to bolt on, okay, using the lug pattern that we have here. And then we're going to slide the dyno in, and we're going to bolt the dyno to this flange here. This is a Dynocom, and I believe mainline, very similar product. So these would work on either or. And so what we had to do to make it easier, I have aluminum soft jaws, and I'll pull the camera in, I'll take a look at that. Just did a simple bore operation with a pretty long reach tool. Did a radius cut in both jaws of the vise to be able to kind of grab and hold on to the outside diameter of this hub here. And the idea is to kind of make it easy. It's already in the program. So basically we're going to indicate this in just for sanity, but I'm utilizing the vise in the program as everything is modeled. So the table, the vices, everything is modeled. We come in, we machine our bore into these lathes, our 2 radiuses in the soft jaws, and then we pop this in, double check indicated. But the idea is that since it was modeled and we're using the same program, the same everything, we're just omitting this for the time being in the program. Now we're going to put it back in, make it visible, and then this should line up with our work coordinate offset, so there really isn't any issue with that. But we will indicate this in for sanity to make sure the holes are where they need to be. We don't want these to be off and have an imbalance or a really bad imbalance on this. So we're going to take care of that, and I'll pop the camera in here real quick again and just kind of give you an idea, a little more explanation, so you can see up close how we're doing this, and then we'll get into cutting it. So let's do that right now. Here is, I have 5 Kurt vices in here. They're kind of like, I abuse the crap out of them. I really don't care. I attempted to do it on here, but didn't want to run into the bolts. So this one, so I just moved it over to here. So we have a radius here, enough to grab. I used a 3/8 helical 3 flute with plenty of reach. That's the tool I'm going to be using to be doing the bores inside the hub and on the outside. Actually, not on the outside, but on the inside of the hub for the 4 lug patterns, the 3 various 4 lug patterns. We're going to set it down here. I'm actually going to space it off of here a little bit since we're boring all the way through. I don't want to run into my vise. Not that I care about the vise, I just care about the tool. So I'll space it off, then again we'll indicate it in to make sure it's where it needs to be. You can see I really just kind of do whatever I need to do with these vices. That's what's so nice about aluminum soft jaws. They literally are a universal fixture. I have a couple videos on that. You can check back on the channel there. I might put a card in here for those too. So right now we'll set that in, see what that looks like, indicate it in, and we will go from there and start programming to do the bores and the chamfers. And I think we're going to use this long reach ball end mill, and what we're going to be doing, this is this is a random size, like a really weird size ball end mill. We're going to use the ball end mill to be doing the chamfers in a bore operation. Easiest way to do it, because it is a specific taper for the acorn style lug nuts that are going to be holding this to the axle. So let's get this all set up, get it indicated in, and we'll get some video of it actually doing the boring and the chamfering. Alright, that's going to do it for this video. We got the hub adapters wrapped up. They came out great. I'm pretty happy with them. I'm going to get these boxed up and sent off to the customer. Again, if you're new here, please consider subscribing. It really motivates me, really pushes me to get more content out to you guys. Like, comment, share the video. If you already have subscribed, please consider sharing the video. It really makes me proud to see the progress of the channel and at a comfortable pace for me, where I can post videos and not be so dependent on it. You can get pretty crazy with YouTube and stuff like that. I really don't want to do that. Right now I'm going to pop in, the last thing for this video, I'm going to pop in a little clip of what can go wrong on a hub dyno if it's not operated correctly. I'm not knocking anybody, I'm not trying to call on anybody, but it can be pretty dangerous, like any dyno. But I guess the person missed an important step of setting up that dyno, so it's pretty crazy. Thanks again, everybody. Check back for the videos, go back and watch some of the other videos I have on there, and we'll see you in the next one.